this assessment, we're asked to predict the product of the dehydration reaction shown. And we're told that there are two products here, so we'll predict both. Now the reaction is going to start by protonating the alcohol to give us a molecule containing a water within that is a good leaving group. So both products are going to form from this starting reaction. With a good leaving group, we ask ourselves, what do good leaving groups do? Good leaving groups leave. So water will take its pair of electrons to generate this carbocation. Now, if we were just doing a dehydration reaction at this point, we would look to form a double bond. But anytime we form a carbocation, we have to ask ourselves, can it rearrange? And remember, rearrangement occurs anytime the substitution of our carbocation is less than that of a neighboring carbon. Here we have a secondary carbocation next to a quaternary carbon, and so we expect rearrangement to happen. Now, in this case, there are two different alkyl groups that can rearrange, and so we see how we're going to end up with our multiple products. The first one that we'll show, if the methyl group transfers over, we'll end up with this tertiary carbocation. Alternatively, we could have a ring expansion, which would give us this tertiary carbocation. From here, we won't worry about showing the mechanism of the next step, but each of these will react to give a corresponding alkene. In this case, for dehydration, we always make the most substituted alkene, and so this one will eliminate to give the new pi bond here, whereas this one here will eliminate to give our new pi bond here. And so the two dehydration products are this alkene that arose from ring expansion in the rearrangement step, this alkene that arose from methyl shifting in the rearrangement step.